Don't sit in.
ज़्यादा लोग नहीं हैं, ज़्यादा तो बहुत हो नॉर्मल। आगे क्वेश्चन गलत कर रखा है।
So good evening guys, we'll be starting now. So for today's lecture we have Aman Buchabhaiya. He is ex-CP head of coding club and he conducted last year. And he's just back from Asia West Continental Finals and yeah, he's a candidate for Astro Code. So yeah, I give it.
Am I audible? Last bench. So originally this lecture had to be on the topic of bit manipulation, but I think binary representation is a more fitting title to this lecture. Reason being, we'll be focusing on how the binary representation of the optimal answer of the question can be exploited in many ways, which is often ignored in competitive programming. Those who don't understand this code, I hope by the end of this lecture you will be able to. So a few things about me. I am a final year BTech student majoring in Maths and Computing. I am from Delhi, and if you visit Delhi, please go to Old Delhi and have the street food. As Shri pointed out, I was the former CP head. My team represented IT Guwahati at ICTC Asia West Finals. Unfortunately, we couldn't make it to the World Finals, but overall it was a great journey. And the rest of the 3 points, I don't know why I added them. So, let's come to some basic properties of binary representation, and I hope all of you are already aware of them. So, if I have a number in binary representation, so let's say D0, D1, D2, and D3, and so on, right? So, in its decimal form, this will be equivalent to and so on. I think you guys know this, right? Anybody who is not familiar with this? Cool then. So if you see, if I have been given a number n, right, the number of bits in the binary representation will be 1 plus log base 2n gif. So basically we need to understand its order of logarithm. Right? So why is it so? Because if you see here, we keep on dividing the number by 2 and just note what the remainder is, right? I hope you guys know this. And if we keep on dividing it, we'll eventually get to the number 1 or 0, right? And that will happen if we keep on dividing to log n times, right? Because 2 to the power log n base 2 gives me n, right? Do you want any further explanation? Cool. The next 3 properties are also very easy. The number of trailing zeros represent the maximum power of 2 that will divide the number. So if the number is, say, any number, right? Let's say 1000101, then 000. So this is an odd number, right? Followed by 3 zeros, which means this number into 8. So 8 is the maximum power which will divide this number, right? Again, we have some few more properties. So, if you see, if I have number 1 and I add it with 1 0, then 1 0 0, 1 0 0 0, right? What will I get in binary addition? 1 1 1 1. Cool. Which is equal to, if I add 1 more to it, 1 0 0 0 0, right? So what is this value? Summation of 2 to the power I, then I goes from 0 till say x. And this value is 2 to the power x plus 1, right? Where x is the number of zeros there. Cool. So a very easy thing to see that the summation of geometric progression which has r equal to 2 can be easily seen from here, because if you add just 2 powers of 2, then you get a bigger power of 2 minus 1. So this is a very easy way to see this. You don't have to apply that formula again and again. Cool. And note that this last property, that if you keep on having a natural number and take its GIF, it will reduce it to 1 or 0 in order of logarithms. So these last 2 properties are used quite a lot in competitive programming. Although they are very simple to see, but their applications are huge. So everyone is fine with those properties, right? Cool. So let's solve this problem. I think most of you, has anyone seen this problem before? Okay. I expected more, but okay. So the question is, a king has m bottles of wine and a large number of prisoners, and exactly one of those bottles is poisoned, right? So the poison works in such a way that if a person drinks the wine, He'll die immediately after, exactly after 24 hours. And the king wants to determine which bottle is poisoned in 24 hours only, right? So he uses these prisoners as taste testers to determine which bottle of wine contains the poison. What is the minimum number of prisoners the king has to use to determine the poison bottle? Clear with the question? So I give you 2 minutes to think about it. Anyone solved it? Yes.
Log 5.
Log?
5.
I think I haven't specified the number.
It's a log.
Log base? Yeah. Not exactly to like 1 plus j of, right? Okay. So anyone who doesn't understand this? Be a bit more responsive, guys. Yeah. So, yeah, you, the one who raised his hand. So, like, what do you think should be the optimal answer for this question? M, okay. So, see, I saw this question first when I was in class 10. I was preparing for Technothon. So, if you have M wines, right? Definitely, if I have M prisoners and I assign each prisoner a bottle of wine, then I'll see who dies, right? The index of the prisoner will be the index of the poison wine, correct? But then if, suppose I have, right, let's say the first prisoner brings these 2 wines, cool? The second prisoner brings these 2 wines, and the M minus 1th prisoner brings the last 2 wines, right? So if the M minus 1th person dies, it means that the last bottle was poisoned, right? If the M minus 1th and the M minus 2th person die, it means that the M minus 1th bottle was poisoned, get it? And so for each combination of the prisoners which die, I can get a unique bottle, right? So instead of 2, if we increase it to 3, right? We'll still be able to do it. Getting this, just shift this window, right? And eventually the M minus 2th person will drink 3 bottles, right? So if the M minus 1th bottle is poisoned, 2 people will die, right? And for each of the wines from index 3 to M minus 3, there will be 3 people who will die, but their combination, thus the set of the indices will be different. Cool? So how long can I actually increase this window? This window can be of length m by 2. Because if I increase the window by 1, then there will be 2 people in the middle. Sorry, 2 bottles in the middle. If one of them is poisoned, right? Any of them is poisoned, then exactly the same set of prisoners are going to die. Right? So a class 10th version of me thought that the answer should be m by 2. So turns out it isn't. Right? So you said log n, right? How do you know that is the optimal answer? Does there exist an answer which can be less than a log n base 2. No idea. So I'll give you the lower bound of the answer, right? That answer cannot be lower than log n base 2, right? So let's say we have a set of the ones, right? N. Cool. Let the set be S. Right. Let's see the first person. The first person will bring a combination of ones, right? If the first person dies, right? What's gonna happen? We know that the bottles which he drank, the poison bottle must belong to that set. And if he does not die, it should be the complement of that set. Correct? So we can have two outcomes, whether one dies or he doesn't die. Okay? And then we have another set here, right? That the poison bottle must belong to either of these sets and they are complement of each other. Right? So let's say the size of this set was what? M, right? Let this be M1. Cool. Or M1. So one of the sets must be at least bigger than the other set, right? Because one has to be larger than that. So let's suppose that this one was the bigger set. Cool. So its size must be what? M by 2. Right? And now we'll do this again. The second person, if he dies or he doesn't die, right? What's gonna happen? The bigger set must have a size of at least M by 4. Right? Because the union of these two sets is this set. And after X, after like suppose we have X people and all of whose outcomes we have analyzed, we get a set whose size will be at least n upon 2 to the power x. Understood? Cool? Or any doubts you can ask. So what will happen after all these x people we have analyzed? We must get a set of exactly one size, which should be the poison bottle, right? So this value should be this, because we are saying that the size of the size after we have analyzed must be at least greater than or equal to m to the power 2x, right? And what is the size? It is n. So we get x greater than or equal to log n base 2, right? So this is the lower bound of your answer. So analyzing it this way is, if you have seen that the lower bound of sorting is n log n, even there we prove it by making a decision tree like this. So now that we know that the lower bound is log n base 2, can you come up with a strategy where you know that you need at least exactly these many people? So would you like to?
Like we have to decide the bottom numbers between 1 to m.
Mm-hmm.
So like m we can represent by a binary number, and each bit which has for each bit we have to decide whether it can be 0 or 1. So to a person we give all the poison bottle, all the bottles with number where the bit is 1.
Yes.
So if that person died, that means that bit is 1. If that person died.
Cool. So he's saying that if I have x people, right, then let this be x times it. So the first person, this guy will drink wines alternatively. He will drink the 0th wine, not the first wine, the second wine, not the third wine, right? Similarly, this person will drink bottles which have 1 in the binary representation here, right? Similarly, this man will drink bottles which have bottles which are which have 1 in the binary representation at this index, correct? So, if this person dies, we know a 1 will be here. If this person doesn't die, we know a 0 will be here, right? and so on and so forth. For all the bits, we can analyze whether there will be a 1 or 0 in the binary representation of the index of the bottle. Everybody clear with this? Or does anyone have any doubts? If you don't tell me, I'll assume that it's all clear. Cool then. So the second problem is IPL 2. So in this version of IPL, if the team wins its ith match, it will gain points 2 to the power I instead of 2. RCB will win every match that Dinesh Karthik plays and loses all others. But DK cannot play all the matches because he's old. So his initial fitness level is given us as f of t, and if he plays the ith match, his fitness level will drop to f of I, right? His fitness level can never go to some negative value. So what is the maximum number of points RCB can gain in this tournament? Clear with the question? How many RCB fans are here? Right. Anyone solved it? Yes.
We start from the backside of the array and then we see the first fi less than ft. Subtract it and choose that bit and do it from
You guys got it? So clearly, this question involves a property that this number will be greater than, let's say, 40, right? Will be greater than this number, right? Right? So the thing is that if you see the last match, right? So how many matches? 16? 14 only? Okay. So let's say 14 matches are there. Then you will get 2 to the power 14 matches, right? If you win that match. And the sum of all the matches from 13 to 1 is smaller than the number of points which you gain from there is smaller than this number, right? So it's optimal that you play this match. See if the fitness level which you have, f of e, is greater than equal to this or not. If it is, subtract it and do this process for other bits also. Cool? Everyone? Or if anyone has any doubt, you can interrupt me at any time. Okay? And watch this video. Isala Tap Nahi. It's a hilarious one. Ironically, it's true. So, next question. Okay. Merrily spending his last days in this college, our beloved Gunjan Dhanuka decides to update his research website. Please see the note. His website has 1024 pages, and for each web page, he wants to add hyperlinks to 2 different pages. The links should be added in such a way that you can jump from any page to any other page by clicking at most 10 links. Help Gunjan update his website. Basically, you have 1024 numbers, right? Let's say 0 till 1023, right? So you have a graph of these 1024 nodes, and you have to add directed edges from one node to 2 different nodes, right? For each particular node. So it should be that if you start from any node you can visit all the nodes in at most 10 edges. Let's use solve this first. There can be more than one solution to this problem. Depends on your creativity. How are you able to construct it? You can call me Aman.
Say for web page, if we index all the web page, web page index in Python representation is like 1001.
Okay.
So it will have two hyperlinks to 10010 and 10011.
So you are saying you require 10 bits, right? So let's say this is the binary representation, right? It will have a few zeros, and then you're saying 1 0 0 1. Okay, cool. Then
So it has two hyperlinks to 10010 and 10011.
but what if there is a 1 here? So it will become greater than 1024, right?
Then we can have to shift it to
Yes, yes.
zero based index. We can have more based index.
Okay, so you are saying just ignore it, right? Taking it 1024 means ignoring this bit.
I'm saying from 101 we are increasing the bit now. We're increasing the bit now.
Yeah.
Like for the last we can decrease.
You are decreasing it, and how? -1 and -1 divided by 2. No, that won't work.
Basically, tail level of tail level, we keep the tail at one node.
Sorry, could you be a bit louder?
We will keep tail levels of like nodes in first level 1 node, second level 2 node, then consequently 4, 8, 16.
Okay, that's how I started the problem first, but I don't think that's one of it. I think you're saying that you have a group of nodes here, and then another group here, right? Okay. And then another group here, right? So then,
At first level, like 1 node only will be required. From F from F.
okay, here is only one node.
Then on second 2 nodes,
Cool.
then 4,
Okay.
8. Consequently, like it will take 10.
Then
Then first node will collect say
this.
it can collect 2 hyperlinks.
Yeah, so from here to here. Okay.
Then consequently, in second one,
So you are saying this
yes.
and this and then this, right? Okay. So the last one, right? How many nodes this will have? 512. If this has 512, this sum will be 1023. One node is still left, right? You remember in the first slide I showed you geometric progression series, right? Even then if you add it won't work. Because then these, where will these edges move? If you start from here then, or suppose you are here, right? And you want to come here, right? You will do something this and then this, right? So there should be a link here also. Good try. We can? Which root? This? Okay, here is a number extra and you are saying this.
Last to the first.
First. What is the leaf here? This one?
Last.
Achha, this one? To here? Yes? But then, suppose you are here and you want to come here, right?
We'll go through that and
You come here?
it was 9.
Yeah?
And the height would be it was 9.
Sorry?
The height would be it was 9 to reach the.
This line?
Yeah.
Okay, so
9.
from here, the hyperlink is to here, right? You came here and then you want to? Okay. Nice. Correct. You guys got the solution? Exactly. So what he's trying to say that, suppose I'm in this level, right? He's saying, let's go to here, let's come here, and let's come here. Because when I reach here, I have the liberty to go anywhere. But yes, there will be a problem. I think if I am here, from here, if I want to reach here, then what?
We can show that the sum would be at most very.
Actually, it will be 11, I think.
No, like the height would be at most 9.
See, this is 2 to the power 0, right? And this is 2 to the power 9. And here is one extra level. I think this will be representing 1, 0, 2, 3, 5. So, these are about 11 levels.
I don't know why we added the first one.
What? This one? Because summation of these many number of nodes is 1023. I showed you in the first slide, right? Sum of GP. So you need an extra node here. What my point? Good try. So I'll tell you the solution. Kind of similar to this only. I think if you improve on this solution, you can actually come up with an optimal solution. I don't have a lot of time, so I'll skip this part. So guys, see, I have a number, right? From any number, I want to generate any number. This was the basic problem. So I have to do something to this number so that I can gain a particular number in 10 steps. I have 10 bits, right? So one step for each bit, right? So definitely you have to do something, right? So that the last bit becomes either 1 or 0, right? And we also need to ensure that we get this bit. So a basic hint which I am giving you, cyclically shift this number to the left, right? This number bit will come here, right? It will come here. Ignore this, add 1 in the first line, add 0 in the second line. So what will happen after 10 moves? This bit will come here, right? Then in the second move, sorry, just a second. Yeah, you will get a bit here, right? And since we are cyclically shifting it to the left, we'll get this bit here, right? Similarly, in the second move, the bit which will come here will come in the second place here, and so on, right? You guys understood what I'm saying? So in this manner, you can actually generate an entire number just by cyclically shifting it to the left and adding 0 and 1. A follow-up question would be that if instead we didn't have 1024 here, but say n, this approach won't be valid, and this was the original question, because it might happen that the number which you are creating exceeds n, right? Here you cannot exceed 1023, which is the maximum number, and it is valid here, right? So what will you do if instead of 1024 web pages, Gunjan had n pages in his website? He has only one book. So, kind of similar technique only. When I cyclically shift it to the left, right, what I get 2x, right? I am ignoring this bit means I am taking it modulo 1024, right? So, the numbers which I was creating were this and 2x plus 1 modulo 1024, right? Cool. So, if I had n, instead of taking modulo 1024, I take it modulo n. Because what's going to happen is, after 10 moves, I will get 1024x, right? Plus some 2 to the power, some 2 to the power, right? And finally, modulo n. Which means I can have at max 1024 different web pages, right? And since I am taking modulo n, I will have always, n here is less than 1024. So, since I am taking it modulo n, no web page is going to exceed n. Right? You got it? Right? So, you were there. Let's assume that as of now I am not taking modulo, right? Any number which I am representing is by default set to mod n. Correct? What I am saying is n is less than 1024. Right? I had a number x, I got 2x and 2x plus 1, right? Correct? The second time, what will I get? 4x, 4x plus 1, 4x plus 2 and 4x plus 3, right? The next time I get 8x, 8x plus 1 till 8x plus 7. So at the end, what will I get? 1024x plus till 1024x plus 1023. All of these taken modulo n, and all of these numbers, right? Since like 1024x plus c, right? Where c from 1024 till 0, right? And suppose from x I wanted to reach y. Cool. This has been taken modulo n, right? So this is congruent to y modulo n, right? So what will this c be? Y minus 1024x mod n. So you can always get a c depending on your y. Cool. And yeah. What I am trying to say is that you will always have a strategy that if you want to reach y, this c is in your hands, right? You will always get a some c. That's it. So from any x you can reach to any y. Correct? So the reason why I started with 1024 was it was easier to see, and we just had to make a slight modification for n. And this is how you guys should approach in CP problems, right? It's not easy to get the right solution in the first step. Sometimes you can solve for a particular values and then just see the pattern. Remember that we are not math guys here, we are CP guys. So this is a famous quote by Gunjan, do your best and forget the rest. It was his WhatsApp about for 7 semesters. Now he has modified it a bit. It is now do your rest and forget the rest. Here is the next question. Working in Amsterdam, Dhruv Somani realizes he has to travel to Astana to represent IIT Guwahati at the ICTC World Finals 2024. However, he has a strange array of n elements which keeps on changing each second and would leave his room only when the array stops changing. In each second, the following happens. So basically, any element becomes x zone of it, adjacent element to the right. Cool. This is what the algorithm is. Will Somani be able to reach Astana? Which means, will this array ever converge to a particular array? Right?
शिफ्ट होने के बाद इधर आना तो ये भी बांधा तो इसके बाद में किसी को लगाना है इधर बांधा तो इसके बाद में बांधा ऐसा फिर इस नंबर पे शिफ्ट होने के बाद
You guys know XOR operator? Anyone who doesn't know? Anyone? Everybody knows. Hello. I'll give you a hint. Try to check the state of the array after 2 to the power p moves. Anyone? Yeah.
Yes, after 2 and 2 raised to the power n plus 1 moves, the entire array would be 0 after
For any kind of values. After 2 to the power
n plus 1.
2 to the power n plus 1 or plus 1?
2 to the power n plus 1.
Plus 1. Just move.
If the side
Do you have a proof for this?
After every 2 raised to the power p iteration, the array is of the form p1s or p2s or p.
No. After okay.
AI is
After 2 to the power p moves, right? It is AI
XOR
XOR
AI plus 2 to the
AI plus 2 to the power p.
module.
Got it? You can check your calculation. Why is it so? Can you prove it? See, it's very easy to prove it. I am motivating the last minute, right? Again, in CP you don't have to prove everything from scratch. You can observe patterns and check if it's true. So like someone pointed out, after 2 to the power p moves, the array will become this, right? Let's prove it by principle of mathematical induction. Right? We had an initial array A. After 2 to the power p moves, Bi has become this. Right? So what will happen to this array B after 2 to the power p moves? AI?
AI
It will be what? Bi XOR
B
Bi plus 2 to the power p, right? Right? What is Bi? AI XOR AI plus 2 to the power p. What is Bi plus 2 to the power p? AI plus 2 to the power p XOR AI plus 2 to the power p plus 1, right? Right?
Yes.
You know? What is this? 2 to the power p plus 1, right? So what is bi XOR bi? Oh, sorry. Yeah, bi XOR bi plus 2 to the power p. It is ai XOR ai plus 2 to the power p plus 1, right? So if after 2 to the power p moves, a becomes b and b becomes an array with this, right? So after 2 to the power p plus 1 moves for a will become this. So by PMI we have proved it. Cool? Everyone understood this? What I am saying is, I had an array A. After 2 to the power p moves, I got an array B. I had a formula for B. I applied the same formula for B after 2 to the power p moves, and I found that this formula must satisfy how A has changed after 2 to the power p plus 1 moves. And this is true for all p. And since for the initial array, for the initial value of p, it is true, that is 0, then we can say by PMI it is true for all values. समझ गए? So now that we have a formula of the state of the array, after 2 to the power p moves, can we actually come up with the rule for convergence of the array? So let's say that suppose the array has converged, right? So it will be a0, a1, right? Let's call it dash. A dash and minus 1, right? If the array has converged, it means that after, in the next second, right, it's not going to change. So what will happen in the next second? It will become a dash 0 XOR a dash 1, right? This should be equal to this, which means a1 dash should be 0. Similarly for a1 dash, a2 dash should be 0, and similarly for an minus 1 dash, a0 dash should be 0. So the array converges if it converges to all zeros, right? So after some, a very big value, the array should converge to an array which has all zeros in it. So what can be the maximum value of 2 to the power p, right? Note that this is modulo n, right? Okay, because everything is done cyclically. So what value of p should we take here? Anyone? What I am saying is that this was our initial array, right? After first, second, it becomes this. The circle is representing an entire array. And after like a lot of moves, we finally get an array in its converged state, right? I want, since this is the converged state, I want a power of 2 which is greater than this, right? But can we actually get it? This n can be very large, right? And I want a power of 2 greater than n. Trying to understand what I am saying? So what we actually want to say is that since we are doing this modulo n, right? We want the power of this sequence 2 to the power p mod n, right? This can have n minus 1 distinct elements only, right? Sorry, n, 0 till n minus 1. But this is an infinite sequence. So some elements must come an infinite number of times. So if I know that a particular power of 2 mod n is coming infinite number of times, I will use that power because m is finite and this value is coming infinite number of times. So there will be a power of 2 mod n which will come after n for sure. So I just want to check for that particular power of 2 which is coming an infinite number of times modulo n, right? Can you guys come up with such power of 2? Suppose that we have found such value, then what we'll do? We'll check this array, right? AI, XOR AI plus 2 to the power p, and we'll check if in this array all elements are 0. Right? So this part of the problem is done. Now it comes to a more mathy part, that in this sequence, we want a value which is occurring in finite number of times. So I'll give you 2 minutes to think about it. It's fairly easy. Suppose that n is an odd number. Then what? What is 2 to the power p mod n for any, take any odd value of n, right? Let's say let's say 7. Okay. So we have 1, 2, 4. Then what?
1.
8 mod 7, 1. 2, 4, 1, right? All values are coming in finite number of times. Let's say 15. 1, 2, 4, 8, 16. All values are coming in finite number of times. Can someone prove it? Anyone who has done some maths in his plus 2? You know, all of you have done. Someone who is in better maths. You understood this part? कुछ तो बोलो. Yes?
Yes.
Yes?
Yes.
Guys, see. You have 2 to the power x, right? And the sequence of 2 to the power x mod n will have a lot of elements in it, right? I am saying that there must be at least 2 distinct values of x such that this value is same for them, right? Because this value has only, the sequence has only n distinct elements, right? One element must come in infinite number of times. Because if all elements are coming a finite number of times, finite into finite is finite, right? So this must happen mod n, right? You understand basic modular arithmetic? What does this imply? Suppose x is greater than y. So 2 to the power x minus y is congruent to 1 mod n. Right? Right? So let's call this value of x minus y as z, right? Cool. I know 2 to the power z is congruent to 1 mod n, right? See, I took inverse of 2 to the power y. Why was I able to take it? Because for an odd number, the GCD of a power of 2 with that odd number is 1. Inverses exist if the GCD is 1. Guys who have done a course on group theory would be able to understand this better. Right? Makes sense? So 2 to the power z is congruent to 1 mod n, and any power of z then will be congruent to 1 mod n. So all multiples of z will be congruent to 1 mod n. And so 1 is going to come an infinite number of times for all values of odd numbers. Right? Okay. Haan.
Is that relation to correct frame rate?
This one. What I am saying is the sequence of 2 to the power x modulo n is an infinite sequence, right? So there must be a value which has come at least twice, right? So I am saying for x and y, the values are same. So I took the inverse of 2 to the power y. What it will be? 2 to the power minus 1, right? So this value must be congruent to 1 mod n.
So, but for like x equal to 3, y equal to 1, and n equal to 6, can you be verified?
N is odd here.
N is
Odd.
odd. Okay.
That's what I said, right? So I said that this is z, and all powers of 2 to the power z will be congruent to 1 mod n, right? So for odd we have said that we can check for only this value. What? 0? because Z is also yeah, okay, that's maybe. Right? Now what if n is some odd number into a power of 2? Anyone would like to answer? Gautam? Correct. This is our currency here. Let's say n is 2 to the power q into m, where m is an odd number, right? We are going to do this. 2 to the power x must be congruent to 2 to the power y, right? Mod n, right? Cool. Instead of this, let's say for m, right? For for m, right, we get a Zn, right, whose powers are all 1 modulo n, right? So 2 to the power Zm is congruent to 1 modulo what m. Now guys, see this step. Cz is also congruent to 1 mod m. If I multiply some value, say x, right? Or q, this will be congruent to 2 to the power q modulo n. Anyone has any problem in this step? It's not very intuitive. Since m is an odd number, you can actually write it in terms of quotient and remainders. What I have done is multiplied the entire equation by some power of 2, which we can not do as such, but since m was odd, right, we can do this because the GCD of 2 to the power q and m is 1. Anyone who knows modular arithmetic might have some problem understanding this statement, but like, किसी को है problem? Right? You understood the statement, right? So since c can be any value, right? This value will come an infinite number of times, right? In this sequence. So what you were saying, कि 6 पे ऐसा क्या हुआ? So because 6 has 2 into 3, so 2 will come an infinite number of times. In fact, for any value, let's say if it's 12, what the cycle will look like is this: 1, 2, 4, 8, and then 16. 4. For any value which is say 2 to the power x, right, into some odd number, it will start from 1, it will come to 2 to the power x, and will take a complete cycle and finally come here. Understood? So we just had to check for that particular value, particular power of 2 which was coming an infinite number of times, and now we'll take XOR with that index, make a final array, check if it is equal to all zeros, right? Cool. So this problem was framed by Nia and Vikram, and a bonus question for you is: suppose BI is AI XOR AI plus 1 XOR AI plus 2. You will require similar approach, and he has submitted this question. You might see it in the post process a few months later. Okay. So guys, what I want to tell you with the help of these problems was that checking for particular power of 2 might be a useful technique, right, in competitive programming, which is often unnoticed. And even many of the common data structures and algorithms involve checking if a particular bit is set in the binary representation of the optimal answer. Or maybe you can pre-compute the answers for powers of 2 and then construct your solution from there. Right? If you don't understand it, you'll just see in a short time. Okay. Who doesn't know about binary search? You can raise your hands. Everyone knows. I'll just skip this slide then. You don't know. You know. कि सबको आता है. I didn't know it in fourth semester, guys. You are serious? Yeah. Yeah. Answer. Depends, you have to check for that power of 2 and see if it has become all zeros. If it has become all zeros, then yes, you will go to Astana. Astana is the capital of Kazakhstan. Okay? If it's not, then where else? Seriously, all of you know binary search? You don't know? Yeah. The confidence is amazing. I still assume that someone doesn't know. Guys, see, if you have mastered binary search, you can, become a GM or SGM. I have seen codes of some, very high-rated people on CF. They can apply binary search on almost anything, on so unintuitive things you can't even imagine of. So see, binary search is a very difficult topic in my opinion, and it will require a complete lecture in itself to cover it. If you want to study it, then Head Start is good. I had problems with it when I was in second or third, I don't remember. The Codeforces EduTab also has, it's quite exhaustive in its own, and I recommend you it rather than Head Start. So, how binary search was required is that suppose you have an array which is sorted, right? And there are many elements, right? Say 1, 2, 5, 30, 68, 70, 420, and 990. Right? And suppose I have to just check if a particular number is present in the array or not. What I do, I keep 2 pointers L and R here. I check for the middle value, check if that value is less than the number required or not. If it is, then I'll shift R to the middle value. If not, I'll shift L to the middle value, right? So at any step, the length of the interval is getting half. And the first slide has told you that if a value is getting at least half, it will converge to 1 or 0 in log n moves, right? So after log n moves, your set will have at least exactly one element or 0. You can check if that value is equal to this value or not, right? But you don't require this knowledge in CP, I think. In CP, what we'll do is we binary search on the answer. So suppose that you are given a problem where you have to find minimum number of an entity which satisfies a property. Right? Most of the problems are like that. So what we do is, let's say the number of the entity, right? If we have an array for that. So we have this array, the entities like say 1, 2, 3 until 10 to the power 5, right? Those who satisfy that property, we keep it as 1s, and those who don't satisfy it, we keep it as 0s. So we have to find the first one, right? A sorted array and the first value greater than its adjacent value, right? You can binary search on it, right? And when I am solving a problem, if you read my codes, mostly I'll add a comment there. I'll write 0s and 1s and I'll check if I have to find the last 0 or the first one. Right? Because at times we forget it. Do we need to find the maximum value which doesn't satisfy it or the minimum value which satisfies it? Right? So a different way to look at binary search. How do you guys implement binary search? You keep beginning and ending and check for middle, right? Anyone who does anything different? So I'll tell you a better implementation for it, right? This you won't find on web. Actually, I found it on some Nginx code. So suppose we have to search for that value in L to R, right? Right. Now this range usually, what will be the length of it in CD problems? 10 to the power 5, right? Let's say 10 to the power 9, right? We can represent it in how many bits? 30. If you want to ask how I did this, so 2 to the power n is what? 1024, which is 1000 approximately. So 10 to the power 9 is 2 to the power 30. You have a course of COA, right? So JJ will ask you in your entrance most probably that he confuses between, I think, megabyte. So for him it is 2 to the power 20. For people who study science it is 10 to the power 6. So if you guys have, say, 1 TB hard drive, what does that show on your system, the memory? 931 GB, right? Why is it so? For us, computer people, we assume this. For commercial purposes, they assume this. Calculated, you will find that 1 TB for them is 931 GB. What I mean to say is that 931 into 1024 cube, right? This is basically equal to 1 TB. You can try it. Who is taking COA by the way? Who? Himangi. Okay. Then it won't come in analysis. Sorry guys. So let's see this implementation. Right? The answer of the index, let's say, is at a distance of d from here. Right? Right? So what we do is we binary search on d, right? To find the value of the answer, right? What I am saying is that d will have some binary representation in it. Okay? Right? So there will be a limit of this width. At max 30. But if you are working on 10 to the power 5, then 20. Because 2 to the power 20 is 10 to the power 6. So, the value of d we'll check. So, we check that if the number, let's say this is the most significant bit, it can be 1 or 0. So, let's say this is what? D? No. Let's say x, and this is 0. Right? So, we check if L plus 2 to the power x. At this index, is it greater than the optimal index or less than the optimal index? Right? Suppose it is greater than the optimal index. What's gonna happen? Will D have this bit set in its binary representation? Yes or no? Yes? No, na? Because L plus 2 to the power x, let's call it IND, right? IND must lie here, right? If we have set this bit, no matter what we set here, the value will always be greater than this. So we won't reach this index, correct? So this bit must be unset in the binary representation of D, right? Now we check for this bit. Suppose it lies here, L plus 2 to the power x minus 1, right? Suppose index now lies here. Will this bit be set in the binary representation of D? Yes. And why so? Because if it is not set, no matter what you keep here, if all these are 1s, this will still be less than 1 and all zeros, right? So all that value would lie here, the values of all the indices. So this must be set to 1. So in this manner, you can find the binary representation of D. So if you are implementing it, how many variables will you need now? Just this L, because suppose this is set, right? So instead of adding D, you can add to L also. So you won't require any extra variables, just that for loop of bits, right? Earlier you had to require two variables, beginning and ending. Now, none. You guys understood this, or I can send you the code if you want, but okay, one thing also, suppose that L plus 2 to the power x was here, right? So you'll have to add a check that it is at least less than equal to r, right? This check must be there. Okay? Anyone knew about this approach before? Shri? So even in our campus, I think only 2 or 3 people in my batch are aware of this. But it should be known because even though you are not using this approach in binary search, you might be requiring it in some other problems, which we'll see later in this lecture. You understood the gist of this approach, right? Okay. So suppose the next topic is exponentiation. If you want to calculate a to the power x, how will you do? First, power function. Power function has precision errors. No, I have an even better approach. Just do this. Right? But what is the complexity of this? O of n, right? O of x. Also, if you have a very large number, right? Even multiplying it will have some computation power, right? You can't ignore it. Suppose I have a 60-bit number in Python, and I'm multiplying it with a 60-bit number. Right? That will have some computation power. Let's ignore it for a while. You guys know Python? How many don't know? You know, then all of you know C++. Right? Cool. So, what I want to say is that suppose I have to calculate a to the power x in my favorite programming language. I'll set answer equal to 1, I'll keep a for loop, I'll multiply answer by a x times, right? This will be order of x, but suppose x is very large, right? Like very large, 10 to the power 9. I hope by now you understand that any computation involving 10 to the power 9 operations will get TLE on your solution, right? 10 to the power 8, sometimes it might. Anything less than equal to 10 to the power 7, it's fine, right? Okay. So, binary exponentiation in logarithm time. We're constantly seeing log in the entire lecture, right? Have you guys seen the Batman meme? I can be whatever Gotham City needs myself to be. If log is doing something like that. Okay. So how does binary exponentiation work? Let's see. Any doubts till now, by the way? Any doubts? No? So, suppose I have to calculate 8 to the power x, right? What I'll do is I'll calculate a, I'll calculate a square, a to the power 4, a to the power 8 and so on, right? How to calculate this? It is the square of this, right? And so on. How many times do I have to do this? Till log of x times, right? Because I don't require after that, correct? And then what I will do in the binary representation of x, suppose x is what? 1, 0, 1, 0, 1, our favorite binary number. What I will do is, this is a 2 to the power 6 into a 2 square into a 2 to the power 0, right? I have already calculated all these values. So what is the time complexity of this approach? Log x. Anyone has any problem with this approach? Right? Guy at the back. देखा कोई भी दिक्कत है बता दो. Gautam, you understood this? So what I have done is I have stored these values a, like a power sum 2 की power in the array product, right? And then I am doing that prod g is equal to prod j minus 1 square. And with the favorite binary number 1000101, we'll see what bits are set and we'll just multiply it, right? Cool. So the thing is that in many programming languages you have an upper bound of the maximum number, right? Everything is not so cute as Python. So you have to calculate it modulo some number, right? So usually it is 1 plus 7. So the same thing which you are doing till now, you have to do under modulo 3, right? Very easy to do. So like if you are doing this, then you don't have to care of the computation power of multiplying large numbers, right? Because otherwise, I don't think binary exponentiation is going to work because you are multiplying two big binary numbers. Okay, applications then. How do you calculate this number? A inverse mod P. One way is to use extended Euclidean algorithm. I think you would have studied in MA 222, I think. Did you? Right? So, in my template, I use extended Euclidean algorithm because it can work even for non-primes. People usually don't know about it. So what they do is we use Fermat-Little theorem is congruent to 1 mod P, right? This is true if A is not a multiple of P, right? If A is not multiple of P, its GCD with P is 1. So its inverse in modulo field P exists. I'll just multiply it on both sides. So A inverse mod P, right? So instead of calculating this, I calculate this value, right? So in many comparative programming problems, you will have to use inverses. Let's say you have to find the LCR of a number, right? So how do we find LCR efficiently? We calculate factorials of all numbers. Fact I is equal to I into fact I minus 1. Then we calculate inverse factorials. How to do it? Calculate inverse factorial of the last number and multiply it with I, right? Or just say that inverse factorial of I is inverse of factorial of I. Okay. Inverse of I is factorial I, right? So then if I have to calculate NCR, I will do n factorial divided by f inverse r into f inverse n minus r, right? So a lot of combinatorics problems are there in CP. You have to calculate NCR. Then again, a to the power b to the power c. This is the question in CSES, and this question came in Sprinkler test when I was giving my Sprinkler test. That was in my 5th semester. So how do you actually calculate a to the power b to the power c? See, anything here, right? A to the power x, right, is congruent to 1. Sorry, p minus 1 is congruent to 1 mod p, right? So if I take any multiple here of p minus 1, this will still be true. If I add r here, right? So this will be r. So this value, let's say this is equal to m modulo p minus 1 is r. So a to the power m is congruent to a to the power r mod p. So we compute this mod p minus 1, right? if this power is say p dash, then we calculate a to the power p dash mod p. Cool? क्या किसी को दिक्कत है?
मैं तो सीधी कर रहा हूँ तो सीधा
दिक्कत है? नहीं? Now let's see. When I was doing binary exponentiation, what I was doing, I was seeing the binary representation of the exponent. I didn't care about what the base was, right? Base could have been anything. What I was doing, storing in the prod array, the a to the power some power of 2, right? That a could have been anything. So like in one of the problems which I encountered, I created a structure myself. I operator overloaded a multiplying operator and I solved it using matrix exponentiation. That was not the editorial solution, but you can exploit this property if you have studied this concept in depth. So similar thing can be done for matrices. Suppose I have to calculate a to the power p, right? What will I do? I'll store a squared, a to the power 4, and so on, right? And then the binary representation of p will help me computing a to the power p, right? You know how to multiply matrices? 3 for loops, that's it. So, if the size of the array A is n cross n, multiplication will take n cube, right? And binary exponentiation requires log of the power, right? So this will be the time complexity with matrix exponentiation. Now, why do we require matrices in CP? Let's say you want to calculate the nth Fibonacci number, right? That is f of n equals fn minus 1 plus fn minus 2. Everyone knows this, right? And the ratio of adjacent elements, it converges to golden ratio, right? Root 5 plus 1 by 2. So, we can represent it something like this: fn minus 1. This is equal to
1.
correct. Fn is equal to fn minus 1 plus fn minus 2. Fn minus 1 is 1 into this fn minus 1 and 0. So if I want to calculate, let's call this, let's call the initial vector f1 and f2 as 1 1, right? This matrix has A. So A, let's call it B. So AB is B1. B2 is A into this, that is A square B0. And so if I want to calculate the nth Fibonacci number, I require Bn, that will be A to the power n B0. Guys, everyone understood this?
Yes.
ऐसे नींद आ रही तो चले जाओ. Okay. Anyone heard of this term before? Sparse table. You do CP. Sorry to hear CP. Nice. This code is totally irrelevant to the context of the lecture. I just couldn't find a relevant code, so I did something which it is very close to me. You guys know about Simulcast? Anyone? You know? Could you just say a few words about it? She committed suicide at the age of 31, I think. Right? So most of the time she was writing some depressing stuff, and she had the habit of committing suicide after every 10 minutes. Okay. So, you won't actually use sparse tables as such in CP, but the thing is that they are very easy to implement, and I have seen that in intern tests, segmentary and convectories are generally avoidable if you know sparse tables. That's why I took this topic, and with the context of this lecture, this is very relevant to us. So, have you guys seen questions like where you are given some queries and you have to find the minimum or the sum in this particular range, right? So in these questions, usually the size of the array is 10 to the power 5, right? And the query size is also 10 to the power 5. Answering any question in an IJ will usually take order of n, right? So total time complexity will be order of nq. This doesn't pass within the current time limits. So what we do is either we do pre-computations, right, and then find the answer in with some better complexity, usually order of log n, or we sort the queries, right, and then we answer efficiently. So that is a totally different technique. Let's leave it for now. So sparse tables are useful when you have to answer queries, say from L to R, what is the minimum value, right? Like you cannot store for all ranges. There are order of n square ranges. You cannot store their minimum value, right? So how to approach it? Okay. So the idea is to pre-compute for every index what will be the minimum value in the range of I till I to the power 2 plus j, right? So the length of 2 to the power j for all indices j. What can be the maximum value of j? Log n, right? Because 2 to the power log n base 2 is n, right? So what will be the memory complexity? N indices, j is going till log n log n, right? Even n square memory is usually not allowed, right? N log n memory complexity. And how to compute this dp? So if I am at index, so let's say that I have computed till indices j minus 1, right? Now I want to compute for index j. I am here. By j I mean the power of 2. I am here at j I, right? I plus 2 to the power j minus 1 I have already computed. I want to compute for I plus 2 to the power j. That is this, right? So this index is I plus 2 to the power j. This length is 2 to the power j minus 1. Since I have already computed for j minus 1, I will take minimum of this segment and this segment. So in order of 1, we are able to compute for j, right? If anyone, cannot follow up with this lecture, you can ask me anything. You guys understood this? I am going a bit fast, I know. So that. So what will be dp I0? ARRI, right? If the array is ARR. Okay, understood? पहले का क्या समझ? पहले का वो भी थोड़ा थोड़ा So what I am saying is for each index, right? So for each index I am storing the minimum value of a length of power of 2 starting from that index, right? So if I am at this array, this is my index, right? I will store a power of 2 length starting at this index. So what's the minimum power of 2? 1. So this segment, right? Then this segment, and then this segment, and then a length of 8, right? How do I calculate the minimum value occurring in this index? That's my problem, right? Okay. So what I am saying is that I have to calculate for power 4, right? This value. That will be minimum of this and this. A power of 2 can be broken into two equal halves of a power of 2, right? Since I've already calculated for smaller values of j, I know this value and this value, the minimum of which will be the answer for this range. Got it? So what will be the time complexity of this approach? N? See, your powers are reaching till log n, right? How do you calculate dp ij? How much time does it take? See the slide. Minimum of dp ij minus 1. So ij minus 1 was this. I plus 2 to the power j minus 1 and j minus 1 was this. What is the time complexity of that step? Order 1. Order 1. So if I know the number of states and then I multiply it with the time complexity, that will be the total time complexity, right? For each state, I am taking order of 1 time, and there are n log n states. How? N indices, log n powers. N log n states and order of n time power. So we are able to pre-compute it order of n log n. Okay with this? So now, if I have to calculate for any particular number, right? How will I be able to calculate it?
फास्ट टेबल कैसे समझ वही तो ढंग से बाइनरी सर्च भी नहीं कर कुछ तो मुझे पीएचडी के भी लगा बस सोच रहे चलो कोडिंग स्टार्ट करते हैं समझ रहा हूँ भाई सारे पैसे होंगे सबसे पहले निकली थी वो तो बच्ची थी मतलब जो अगर कोई किया होगा तो पैसे चाहिए दोनों का ऐसा किया कर लेना पैसा अच्छा उसके बाद अरे बोल के आ जाए बट अभी चालू करेगा तो
Okay.
मैंने उसको बोला था
Suppose that I have to calculate the minimum from L to R, right? L is here, R is here, right? I have pre-computed the answers for all powers of 2 for each index. So, this length, right? Let's say it has binary representation of 1, 0, 0, 1, right? It is 4, 8 plus 1, right? Right? So, from L, a length of 8, then a length of 1. Got it? Everyone at the back. If the binary representation is say 1, 0, 0, 1, 0, 1, right? This is my array. L is here. This is what 32, right? So 32 length, right? This, then a length of 4, then a length of 1, right? I know the answers for all of them. So I'll take a minimum of all these segments, right? So how much time will it take to answer each query? Log n, because I want to compute the binary representation of R minus L plus 1, right? But in case of minimum operation, see, if it was sum, if you had to calculate sum using sparse tables, this was perfectly okay. Suppose I have to calculate minimum, right? Minimum operation can be seen as a power of 2 from here, let's say this was 32, right? And a power of 2 from here, 32. If these values are getting computed again and again, it doesn't matter, right? A minimum of a set and a minimum of that multi-set will be the same. Got it? So in case of minimum, you can find the minimum in order of 1 for each query. And this is where sparse tables actually shine. And by experienced competitive programmers, they are often used if the array is immutable. Because in queries questions, most often you will be given that there is some update if you have seen some CV problems. But here we have assumed that we are not changing the array. I will just tell you why. So here are some advantages, easy to implement, minimum and maximum found in order of 1, right? What are disadvantages? Can be used only on immutable arrays, and most range queries use in updates. So why is it that we can't use it for updates? Yeah? Samajh that? Okay, you have pre-computed the array, right? If you are changing a particular index, right, you have to do changes in the DPR. How much time will it take to change the DPR? N? No, it's wrong. No, I'm saying that you are given a particular query, right? Which says that change the value of a particular index in the array to this value. So the DP array which you had formed right now, it will change. How many changes will you have to make? Someone said n log n, right? I'm saying it order of n. I'll tell you why. Suppose this is our array, right? And this index has been changed, right? DPI0 will change. DPI minus 1, 1. DPI1 will change. DPI minus 2, 2. DPI minus 1, 1. Sorry, 2. And DPI2 will change, right? So, if j is 0, how many changes? 2 to the power j, which is 1. If j is 1, again, how many changes? 2. Getting my point? If j is 2, how many? I mean, the length of the segment. If it is 4, then how many changes? 4, right? Because that index can occur at any place in the sub-array. If it's of length 8, then 8 changes, right? This will happen till it reaches n. What's the summation of this? Bounded by 2n, right? Because this is what? 2 ki power log n. What's the summation of this series? Bounded by 2 ki power log n plus 1, which is 2n. So order of n changes you will have to make, and not n log n, right? So even if you have to change the array, right? Since you have q queries, you can make order of nq changes. That's why sparse tables are not used for updates. They are used only for immutable arrays, right? If you don't understand it, I hope you got the gist of what we were doing here. We were pre-computing for powers of 2, right? And then the binary representation of the query which is given to us of r minus l, we will compute it from that. If you get it, then it's fine. So, here is a problem for you guys. Sharma and Sri are the current CP heads who have organized this wonderful event for all of us. And they are very busy with their schedules because they have to interview the next, who will become the next CP head of the institute. So they assign the score of I candidate as AI, right? But Sharma has mood swings. So he will give lower scores to people who will interview at end. And that's why Shri uses his mind and defines the new score of the I candidate as taking it modulo AI plus 1, then this value modulo AI plus 2, then this modulo again and again till it reaches AI. So help Shri find the array B efficiently. What is the naive way to do this? What is the time complexity of the naive way? Order of n square, right? But if n is 10 to the power 5, it won't work.
सही था
You guys understood the question?
वो उसमें एक उठा के आगे रखना था होगा क्या था रेटिंग को सिमिलर सा था
Then what? You first take n minus 2 mod to n minus 2, then mod n. Any ideas? Till now? What? कैसे? But then, if you have to answer for this range, and you have an answer for this range, how can you join these answers to create a new answer? This value is what? A mod B mod C mod D. This is mod X mod Y mod Z mod Z. So with these two answers, can I compute X mod Y mod Z mod A mod B mod C? A mod B mod C is not equal to A mod B mod C. Right? Associativity is not there. If the operation is not associative, you cannot build any data structure on it. Be it sparse tables, be it family tree, be it segmentary, any kind of data structure which you will come across in CP will require the operation to be associative.